background, is ask the user for a number, check it to make sure it is a number. Actually, we're going to ask them for an int. If it's not, make them re-enter it. Alright, so we know we're going to need an input statement. That's one of the ingredients of this recipe. What else are we going to need? If we're going to make them re-enter it, what does that kind of imply? Would we a while, because you wouldn't just use an if statement. That would only give them one shot at it. So let's do good is equal to false. And then while not good, or we could write while good is equal to false. You know, either one works. While not good, let's get some input. I is equal to input. Please enter an integer or a whole number. Users don't want to see words like integers. Please enter a whole number. Alright, now if we just do this, if I just did this, if they type in something bad, it's going to crash. And we can demonstrate that real good. At the bottom, I'm going to print I. Okay, this is a bad program because it's never going to leave the while loop. Why? Because the condition never changes, and there's no break statement. So it has no way of leaving a while loop. It's an infinite loop. But we've seen this, right? You run it. It's asking for an int, or it's going to try to convert it to an int. Since I'm not going to enter an int, it's going to blow up. We don't want that. Don't want programs to crash on bad input. So what we want to do is, before we try to turn it into an int, we need to check it. We saw some string functions that would check to see if the string was composed of digits. In the password program, we used it on a single letter, but you could use it on the entire string. What is the string function that checks to see if input, if a letter or a string is a number? Is digit. Right, it's is digit. So, if I dot is digit, colon, then it's great. Let's convert it. And let's set good equal to true. Else, we're going to print an error message. That wasn't a whole number. Honestly, I don't remember if is digit or not allows periods, you know, for punctuation. I mean, you know, for decimal points. That'd be worth testing out. Let's find out. Clear. That's never going to go away, is it? Please enter a whole number. Blah, blah, blah. That wasn't a whole number. Please enter a whole number. 100.1. That wasn't a whole... Okay, it's working the way I want. Now, in a way, it's a shame that it doesn't allow a period, because if you were checking to see if it was a floating point number, then it would yell at you that it wasn't a floating point number just because you entered a period. So this technique is not good enough to handle floats, but it's good enough to handle integers. And in a lot of cases, you might use integers. You know, you ask the user to pick, you know, from a menu choice, 1 to do this, 2 to do this, 3 to do this. You want to force them to pick good input, you know, that kind of thing. Or you want them to enter their weight as a whole number. You could tell them not to enter their weight as 144.5. Although really, you know, some people are crazy enough about their weight that they wish they could. So you might not want to make that restriction. Age. Nobody says that they're 23.12 years old. I don't know. It'd be kind of fun to figure out and start entering it in forms. But nowadays, everything's a drop-down menu, you know. You were born in June, you know, 3, whatever. And if you're old like I am, it takes forever to scroll down to your...
Take the whole number component away from them.
Yeah.
Choose specific values.
Yeah. Okay. So that's one way to check to see if input is good. There is a more techie, complex way. Well, it's not more complex. There is something known as exception handling. I'm going to put a comment here. Exception handling is when your program hits a runtime error. Do you remember what a runtime error is? What is a runtime error? Somebody tell me. Yeah.
Where it crashes.
Yeah, where it's going to crash. Where we just saw a runtime error when I typed in some bad input and the program crashed with some red writing on the screen. Red writing hood. All right, anyways. So, exception handling, that's technically known as an exception. It got to a state, an exceptional state that it couldn't recover from. But programming languages usually have a facility for handling exceptions. And I'll show you what it looks like. Try this code, please. X is equal to 1 divided by 0. Print X. No, print I did it. I divided by 0. I am so cool. All right, there we go. And then you put something down here, except if it breaks, if we hit an exception, that means we got a runtime error, and we're going to try to recover from it. Print, I'm sorry, I can't do that, Dave, if you're a 2001 fan. Okay. And then I'm just going to print a done here. All right, please enter whole number 1. And then it said, I'm sorry, I can't do that. The reason why is because it hit that divide by 0, which would have generated an error if I hadn't put it in this try block here. I think I've demonstrated that, towards the beginning of the semester. You divide by 0, you get, the red messages, it fails. Program stops. But this catches it. Well, this try except stuff works also, on conversion errors, like if you're trying to get something into an int or a float. So we're going to repeat this code up here, except we're going to use try and except to handle the errors, which is even more reliable if you're trying to do a float, because a decimal point is acceptable for a float, but it is not acceptable to is digit. And I don't want to do is digit and, only one period, something like that. So we're going to do the same thing again. Good is equal to false. Sorry if I went too fast, guys. Good is equal to false, while not good. Remember, that's the same thing as just saying while good is equal to false. Also remember that when you get to other languages, instead of the word not, you're going to use an exclamation point. Most of them do that. Don't know why not. They don't implement not. It's a perfectly good word. Okay, so let's ask them for a number. Yeah, thank you. I deleted the word not, and then it would have behaved in the wrong fashion. It wouldn't have gone into the while loop. Okay, so while not good, let's ask for a float. I'm not going to even specify whether it could have decimal points or not, because we're going to change it into a float, so it doesn't matter if they enter a decimal point or not. So this is the point that could fail, the conversion. F is equal to float f. That's the point where it could fail, so we're going to put that in a try block. F is equal to float f. If that works, if it gets past that statement without blowing up, then good is now equal to true. But if it fails, if we get a runtime error, it's going to jump down and execute the except block. In which case we want to print an error message. Print invalid input. We don't really know what's wrong with it. Maybe they enter 2 decimal points, maybe they type their name instead of a number, whatever, We just know that it failed, that we got a runtime error. Other languages let you get more specific. what kind of exceptions you're catching. Did you catch a divide by zero? Did you catch a conversion number? Did you catch a could not open file? That kind of stuff. Alrighty. And then once we get out of that, we're done with the while loop. So I'm tabbing all the way back. Okay, that was a good number. This program's output's not going to make a lot of sense. It's going to be saying things like, I'm sorry, I can't do that, and then done, and then it's going to keep going. I think I'll delete that done. Don't need that print done. Please enter a whole number. All right, I'll do that so it won't keep yelling at me. I'm sorry I couldn't do that. Enter a number. I'm going to give it some bad input. It didn't give me the red error. It caught that runtime error. It caught that exception. So it executed the accept block, which said invalid input. All right, I'm going to give it a good number. But I'm going to just put in 2 decimal points. It's still telling me that's invalid input. Okay. Just 1 decimal point. Okay, that was a good number. So we've seen 2 different ways of writing a loop that would check to see if input is good or not. Technically, this is a better way of doing it because it allows fractional input if that's what you're hoping for, you know. It allows floating point input. The first way is perfectly good if you're just trying to convert it to integer input. But the second way would work for it as well. I'm going to take this code. You don't have to do this, but I'm going to cut that and move it down to here so that it's closer to the other one. And I'm going to put some comments in here. So this is above the one that used isDigit. So here our strategy was use isDigit and a while loop to require or to guarantee good input. Then I'm going to go down a little bit to that other while loop and say strategy use exception handling, a try and except block to guarantee good input. And you'll find that in professional programming you put in a lot of error handling because the users can make a lot of mistakes and there's a lot of things that can go wrong. You're trying to write to a file but they've pulled out the flash drive or the disk is full, or you're saving to a bad file name. You've gotten that error when you try to create a file name that's got a slash in it or something like that and it yells at you. I think on a Mac it's a semicolon that stops it from being a good file name. At least it used to be. And or you're trying to open a file on the internet but your access has gone down, your Wi-Fi has gone down. You know, there's any number of error conditions that can come up. They enter bad data, you know. So professional programming involves a lot of error handling, unfortunately. And when you're a programmer, what you typically do is you write a program in order to get it to work right, you know. And so you write a program and you test it with good data and woohoo, it works. Well, you also have to try to break it. And that's what the testing department does as well if you work in a team with a testing department. So along with isDigit, you can test for other conditions. What were some of the other conditions that we used? Not only isDigit, we used some other ones. Like for our password program, what else did we use? Pardon? Yeah, we did is upper if the entire string was uppercase. We did is lower. Any others? To check for specials, I guess we used is alpha and isDigit. We used a combination of those. So is alpha, make sure it's a letter. And then there was one that checked to see if it was either a letter or a number. I'm not sure we used that in the password program.
To check for spaces, wasn't it?
Yeah, there was this space. Very good. Spaces, tabs. Then there is alnum, which means alphanumeric, which is a letter or number, obviously. That's getting to be most of them. There may be others. So is digit is if it's a number, obviously. Is uppercase if all uppercase. If all lowercase. If all letters. If all spaces or tabs. Alright, so if you wanted to do something like check to see if they entered some good input, you know, the user has typed in, you know, choice is equal to A, but you really just wanted to check one thing, you know, like if their choice is equal to A, but you also wanted to see if they entered a lowercase a, there's a couple ways you could do that. You could use an or you could convert the input into uppercase. So you could do this. If CH is equal to A, now here's a mistake people make, or A. Looks good, but it's not right. What's wrong with that? Anybody who got this error should know. Yeah.
You have to use an entire expression.
You have to use an entire expression on both sides of the or. If you deleted all of this, that still needs to work. So yeah, you got to put or CH is equal to that. Except you better not forget your quote like I did. The other way you could do is to just convert it to uppercase. If ch.upper, the uppercase version of it, is equal to A. And that's kind of nice if you're presenting, you know, a list of options and you don't really care if it's all lowercase or uppercase. Or, you know, if you're going to print a mailing label, you may as well convert it all to uppercase before you print it. Kind of helps the OCR things that handle mail.
So if you write it the second way, it doesn't matter if it's upper or lower. You're going to see it.
It still will see it, even if they type in a lowercase. So we have a lowercase a here,
Right.
but it's going to say that and it's going to say that. Both of those checks. So let's check to see if it is an uppercase or a lowercase. And then here, check to see if the uppercase version is an A. Or you could use ch.lower and check for a lowercase a. That'd work. For some reason I like converting things up rather than down, but you could do that. You could write, I'm going to delete this. Yeah. That'd work just as well. So along with dot upper, which turns the string or letter uppercase, then you have dot lower, turns the string lowercase, and then you have dot initial, which gives you initial caps, like a proper noun, a name. That word turns is beginning to look unprofessional, but I'm going to go with it. Turns the string into words with initial caps. I'm just going to change that. Makes initial caps. Bless you. One more really important string function. There may be others. I think there's like dot find or something. That's a pretty good one if you want to find the location of something in something. You want to search the entire string for the $sign. That one's pretty important. Let's test it out to make sure it works. If I have it, I'm going to tack it onto the very top. But then I'm going to move it down to the south so you can put it down there. Let's say that we have something called money, and it equals to I have. And let's put it at the bottom. I don't want to be confusing. I'm going to go back down here. Okay. So say we open a file and it says I have $3.45, like that. But we just want the $3.45. We don't want the rest of it. We're going to try to find the location of the $sign, the symbol. So start is going to equal to money.find that $sign. If it's less than 0, it means it didn't find at all. I'm going to put a comment here that .find searches the string for the position, the index value of X, and returns it or -1 if not found. So if start is less than 0, we didn't find the $sign. Else we ought to be able to use that to get the rest of the string. So we're going to use slicing. We want to start at 1 past the $sign and go to the end of the string. That's not a totally great idea, because what if they did that? But let's just roll with it. Else, tell you what, if it says no $sign found, let's set money equal to 0. Else we need to get only these pieces of data right there, so we're going to use a slice. Money is equal to, how do you do a slice? You use the square braces, and you give a starting position and an ending position, or if you don't give an ending position, it goes to the end of the string. I think if we do start all the way to the end of the string, I think it's going to be close to what we want, but I think it's going to include the $sign. And then let's convert it to a float. That's going to blow up, because it's going to include the $sign. So let's do start plus 1. We want to skip the position of the $sign. And then let's print out the money. So to really get the dollar value, what we probably ought to do is search for the next non-digit character. You know, once you find the $sign, you keep going until you find a non-number. But I don't want to make the example too complicated. Yeah, we'd have to include the decimal point. Maybe we could go 2 past the decimal point, because most people don't enter that. It's the dollar value. That'd work. And it found it. It found the 345 out of it. And we used that way back at the beginning when we were opening the web page for the price of the coffee. We used .find. So these are terribly important string functions, especially .find. Yeah, converting things to uppercase and lowercase is important, but searching data for a specific value is really important. That's how you could rule out whether they had a Z or not, by the way. If instead of counting the number of Z's, you could just use if .find Z less than 0, then print no z's found, that kind of thing. Just like we did here. We looked for a dollar sign, and if it was less than 0, we printed that we didn't find a dollar sign. It's just an alternate strategy. If you're only checking for its presence, that's enough. And then lastly, dot split. Dot split turns a string into a list. I'm going to go tack that onto the comments so that these are all in the same place. Turns a string into a list based on spaces. If you want to use something other than spaces, like you want to use commas, then you'd have to specify that you want it broken up by commas. So let's make a list. I don't know of what. Data is equal to, let's type in some numbers. Now I want a list. I'm going to use capital L rather than lowercase l. I could use the whole word list. List is nope. List is a reserved word. List is equal to data dot split. When that's done, if we just printed out the list at this point, we would see that it's actually a list now rather than data. Let's print out the data and the list, just so we can kind of compare them. Alright, see, here's our string, and here's our nicely divvied up into a list. Why would you convert it into a list? So that you can process each one. And you can be sure that if you type in, if you're writing a program that's analyzing text, you're checking someone's email for, instances of bad words, and you don't want to let them talk about, terrorism or whatever, that they're breaking it up into a list in order to run a search on it, to find out whether it's got, any prohibited or suspicious words in it. There are all sorts of times when you're converting input into a list. For enter, obviously for data entry like that, that's a good way to do it. Okay. So, turning a string into a list is important. Say that we have those numbers and we want the maximum value and the minimum value and the average of that list. We kind of did this, or this was one of the homework assignments, and if you didn't get it done, then I'm giving you a good clue. The only thing is we're not filling it with random data, as the scores program asked. So, let's get the total of the list. So we're going to use the sum function. I'm going to make another little list in the comments about good functions to use. Sum obviously gets the total of the list. And then there's max, which gets the maximum value of the list. And then there's min, gets the min value of the list. And then there's length, get the length of the string or list. I'm going to go back and put L's in here just to imply that you pass data into them. Why didn't I do that up here? Because these guys don't require arguments. You're just turning it to uppercase. You're just turning a string to lowercase. Yeah. I might be wanting to put s.upper or s.lower or whatever, but hopefully you know that if I put dot in front of it, it's a function that's attached to a variable, so you have to prefix it with a variable. Like turtle, t.forward for a turtle, that kind of thing. Okay. So total is equal to sum, largest is equal to max of the list, I'm going to just change that to large. Smallest is equal to the min of the list. And the average is equal to the sum of the list divided by the length of the list. And we could print all those out. I'm not going to even bother printing them out. You know how to print. Don't let this confuse you, but I'm going to cut those comments. Whoopsie. I guess they're good where they are. I might rearrange them when I turn these into notes. What if I wanted a for loop that would step through that list? We talked about two different for loops. What were one of the two different kind of for loops?
For each.
Yeah, there's the for each or the for value loop, and then there's the other one. What was the other one? I thought I heard you say it. Nope, the for range. Yeah. So, for each, excuse me, I'm going to rewrite that. For value, also known as for each, and for range. So for value in the list, print that value. That's how easy that one is. If you could use for range, the syntax is a little bit more complicated. Not that bad. I use I for index number, just personal quirk. For I in the range of the length of the list, print.
Put equals instead of in.
Yeah, you're right. I slipped into writing basic there. For I equals 1 to 10. Okay, there we go. Ah, I did it again. Okay, thanks. So print the list at that specific value. So this is a for value loop, and this obviously, and that's a for range loop. What else? We haven't done reading from or writing to a file, have we? We may cover that on Monday. Since that'll be right before the exam on Wednesday, where probably won't show up on the exam, but it's an important concept. So don't skip Monday. Wednesday. Let's make sure that's in D2L. I think my comment on that was that your other exams may be on Monday or Tuesday of the following week, but we're going to knock it out early if that's okay with y'all. So our final will be Wednesday the 26th. Note that this is probably not the date of your other Wednesday finals, which may be July 31st. Alright, too early for a break, but I do want to move on to another subject, so let's switch gears. We're going to go back to that textbook that we don't hit very often. The Head First Programming. And we're going to have to make some modifications to it. One of the reasons why I don't give homework from this thing is because we keep having to modify it as we do it, but that's okay. Specifically, this relies on a library that I do not believe we have on these machines. We could check. Alright, so I opened it up as a PDF because if you use that little preview program inside D2L, it's really not very good. So save the document and then open it up. Okay, going all gooey. Your coding skills are great and getting better all the time. It's a shame that your programs are not that nice to look at. Well, how rude. You're so judgmental. Displaying prompts and messages on a text-based console is all well and good, but it's so 1970s. Add some green text on a black background and your retro look would be complete. There ought to be a way to change the color of the text. I bet there is. There has to be a better way to communicate with the users in the console, and there is, the graphical user interface. That was popularized, in the mid-'80s with the Mac and in the late '80s with Windows. Not that either one of those people invented it. Sounds cool, but complex, but it can be. But don't fret, learning a trick or two will have your code all graphical in no time. By necessity, writing a Windows-based program, a GUI, a graphical user interface, is more complex than writing a text-based program, just because you're handling things in a different way. Okay, so there's a library called Pygame. Let's see if we have Pygame. I'm going to go to the shell and type include Pygame. No, wait, import Pygame just to see if we have it. No, didn't think so. Okay, so we're definitely going to have to modify any references to Pygame to not use it. Pygame's a cool little library. I've seen people write like Space Invaders type programs where, not quite, but where you're a spaceship and things are falling towards you and you're shooting them. And somebody was trying to write, a platform-based program where you were running left and right and jumping over things. You can do some pretty cool stuff with Pygame. Once you get out of this class, if you wanted to research that, it's not like you're going to be writing Call of Duty with it, but you can get some, little primitive games going, learn more about programming that way. So that didn't work, but let's go see what they're trying to cook up here. Alrighty, so we're not going to do this, but the first thing the text had us do is write a little program. Press 1 for correct, 2 for wrong, or 0 to quit. We're keeping track of the number of right or wrong answers. Apparently we're a quiz score moderator. Every time they get one right, we're going to press a 1 on our program. Every time they get one wrong, we're going to press 2. And then we can tell them how many they got right. 10 were answered correctly, 4 were answered incorrectly. That's where our program is going. That looks great. I can't wait to try it out for the semifinal. Okay. 1, 2, and 0 pressing keys. That's so 1985. Your program's looking dated. You want a graphical user interface or a GUI. We need to design the look of our interface. We want something that looks kind of like this. Correct answer, wrong answer. So, we're sitting here, we're moderating the quiz show. Every time they get an answer right, we're going to click that one. Every time they get it wrong, we're going to click that. So we definitely need 2 buttons. When they click either one of these, that's known as an event. And so we're going to add event handlers to our program. An event handler is something that responds to something on a graphical user interface. What are events? Well, somebody minimizes it. Somebody exits the program. Somebody moves the window. A lot of events nowadays are handled by the libraries themselves, and we don't have to manage them. We don't have to respond ourselves to a minimize and a maximize. Used to be you had to do all that yourself, and so your programs were very long, even if they were very simple programs, in order to handle all the possible events that your program could be sending to you. And programming has been made simpler by the addition of libraries. So there's a library called TK-Enter, I-N-T-E-R, not E-N-T-E-R, which stands for interface. So to handle events, we need what's known as an event loop. The event loop waits and watches for events, calling a piece of code each time an event occurs. But with tk-enter, we don't write a while loop. Instead, we just call something called main loop. You know, on our turtle program, we called some kind of loop at the very end that would just sit there, and then the window would stay on the screen until you closed it. That's kind of the idea behind calling main loop when you're using the tk-enter library. Except it sits there, and not only is it waiting for you to close the window, it's waiting for you to press some of the buttons on it. And if you press a button on it, it sends a event to your program. A different event for each graphical object on your screen. You've got 2 buttons. It's capable of sending 2 events. So let's see if we can write this itty bitty little program here. Let's make a new program. A new idle file, new Python file. I'm going to call this one GUI game, GUI game. So our first line, we're not going to use the turtle library, we're going to use the tk-enter. Oh, that's annoying. From a new syntax for us. tk-enter import star. There's a reason we're doing that. If we just did this, if we just did import tk-enter, then every time we use something from the library, we'd have to preface it with the words tk-enter. You know, so we'd have to do, don't type this. We'd have to type app is equal to tk-enter dot tk, like that. So I guess all along with the turtle library, we could have been doing this alternate syntax from, you know, turtle, import everything. So that way we wouldn't have to type turtle dot. But we'll live with it. Okay, so from tk-enter, import everything. Now we're going to create our application window. We're going to give it a title. App.title, my awesome window. Now this is interesting. Honestly, I don't remember what all these numbers do. Clearly it positions the window, sets a screen size for it, but I'm not sure what the pluses do. But I'll run with it. App.geometry 450 times 100 plus 200 plus 100. I'm sure they will explain. I'm going to use double quotes. I like double quotes. What that does. And an app.main loop. If I didn't make any typos, and we have the tk-enter library installed, then when I run it, it should create a window. There it is. It says my awesome window. My guess is that 100 and 200 is the margin away from the corners of the screen. I'm going to change those numbers to see if that theory is correct. I'm going to make this plus 50 plus 50 and see if it's closer to the edge of the screen.
Why the X instead of the star? You just asked this one.
Why the... because I'm typing the example. That's the cheaty example. That's the cheaty answer. The real answer is that this is not doing math. If it was, then it would be adding 100 plus 200 plus 100, and we could have just typed in, 400 there, which is not what we did. Instead, this is a string that is going to be parsed by this function. And so what it's going to do is it's going to look for the first number, and it's going to use the x to divide the first number from the second number, and then it's going to use the plus signs to adjust the margins. And they absolutely could have chosen a star when they wrote the library. But they didn't for whatever reasons that I can't explain. So it's just a symbol that indicates the size. we didn't pick it, but it's not math, so it doesn't have to be an asterisk. Does that make sense?
Yeah.
Kind of arbitrary on their part. I wonder if an asterisk would work. Since you asked that, let's find out. Nope. Okay. Very good question. Okay, so hopefully this is pretty clear. That one creates our window. That one sets a title for it. That one sets the correct size for it and the margins away from the screen. Seems kind of silly. What if I just wanted it centered? I'm sure there's a way to do that. And then it goes into a loop waiting for us to start clicking stuff. Now that's a boring window. It doesn't have buttons or anything, so it just sits there and waits until we close it.
If you didn't have the main loop on there, would it pop?
Would it pop the window and then quit? Let's find out. I believe that to be true. Huh. Still seems to be there. Good question. We'll play with leaving that off later as we actually add buttons to it. We'll see if it's necessary. Alright, so we're going to add a button to it. And the syntax for adding these buttons is going to, it's not that complicated, but it's a lot of typing and there's a lot of opportunities for typos. So you're just going to have to be very careful. And I'll be happy to wander around and make sure. So what we want to do is we're going to add a button, but it has to be before the call to main loop, because once it hits main loop, it starts running until the program is closed. And so all of our code here needs to be before that. So we're going to say B1 button. And I'm putting it before the main loop call. Is equal to button with a capital B. We have to specify what window we want the button to be in, so we're going to call it app. Then we have to put some text inside the button. Click me. We have to say how wide we want the button. You know, these monitors are like 1,000 pixels or 1,200 wide. I really doubt that it's going to merely be 10 pixels wide when it's displayed, because that's just a sliver. I wonder what units it's measuring in. I bet 10 characters. You know, room for 10 characters, but we're only filling in 1, 2, 3, 9, whatever. Okay. You can't just add a button though. You then have to call a function called pack, which will arrange the window and put the button in it. Kind of like, you buy some clothes, but until you pack it in the sack to go home, it's of no use to you. That's a dumb example, but it's the best I can come up with. Pack. Click me. Neat. Not doing anything because there's no event handler for it. There's nothing in the code waiting for the button to be clicked. But we've got a button on the screen. We're well on our way. We could add more buttons the same way. Just copy this line. Copy both these lines. Paste them, but change them to B2. See if we get 2 buttons on the screen. Yeah. It's going top down. I wonder if we could get them side by side by waiting to call pack. This is just an experiment. You don't have to do that because I'm not sure it's going to matter. Nope, didn't matter. I wish this was more like .add, rather than .pack, because .add would make sense. Add this window to, add this button to the window. Okay, so we have 2 buttons. We've packed them, we've added them onto the screen. We want to make the button do something, print a message, something like that. I think in the example they have these buttons, play sounds and stuff, but we don't have the Pygame library installed on here. I thought I asked for that. Oh well. TK Enter is packed with options. If you want the buttons to go on a side, you specify. Pack side is equal to left, it'll push it to the left. Pack side is equal to top, it'll go to the top. If you want to put some padding around them, you can add some parameters. PAD X is equal to 10, PAD Y is equal to 10. That would put some 10 pixels around it, the button. Okay. So since our program was supposed to say right or wrong, so that we were counting or correct or incorrect, let's put better text on our program rather than just click me. So rather than click me, let's say right, not logic, right, and then wrong. Run early, run often. There we go.
How do you move to the side, right and left again? Pack side something?
Yeah, pack. Let's get the precise syntax. Side equals top, bottom, left, right. Let's give that a shot. So pack side equals top. No, left. And then the other one, pack side equals right. There we go. Cool deal. If we put some margins on them to move them closer to the center, that'd be neat. If we made the text bigger, that'd also be cool. I'm not sure how far this text takes us. I've kind of forgotten. So we'll see. Yeah, they did add some padding to it. They did pad X is equal to 10, pad Y is equal to 10. Put some space on it. We can do that. Separating everything by commas. It's curious that this was all one string, but that here we're specifying things individually. So pad X is equal to 10, pad Y is equal to 10. And then on the next one, pad X is equal to 10, pad Y is equal to 10. Give ourselves some margin. Alright, that's really not very much space. I'm going to change it to 50. Pad X 50, pad Y 50. Oh, neat.
Just change the X value instead of the Y.
Yeah, so it's pushing it off the screen. Cool. As an experiment, I'm going to comment out this geometry line and see what it looks like. That's what I thought. We didn't specify a size for it or a position, so it's kind of defaulting to a size just large enough to hold those buttons. That's kind of cool, actually. But I'm going to undo it. The reason they specified a size, I think, is because I'm not sure what would happen if you created an empty window and did main loop, if you'd see anything at all. We could find that out too. Don't do this change. Well, it comes out a perfect square. Okay, anyways. So in my opinion, setting the geometry wasn't quite necessary because I like it resizing to the data that we add to it. We saw that when I messed up and set pad Y equal to 50, it was pushing that stuff off the edge of the screen. Whereas if we didn't have a geometry, that would have worked. Nice interface, but it doesn't work. When I click on a button, nothing happens. I don't hear anything. What happened to my cool sound effects? Well, we're not going to get cool sound effects. So the interface is defined, but it's not doing anything because it doesn't have any event handlers in it. So all TK-Enter gives me is the ability to draw a graphical user interface? Well, yes, but that's quite a lot of functionality, and that's actually true. Back before you had libraries, you had to write so much code to do something simple like putting buttons on a screen. I could go and find you an example of code like for 1989 for displaying windows on a screen, and it's hundreds of lines long. The pack method looks a little weird. How does it know where to put things? It adopts a best guess approach. It usually works. When it doesn't, pack's parameters give you some control. Okay, I get that, but how come nothing happens when I click on my buttons? Ah, funny you should ask that. Okay, what we have to do is add this parameter when we create a button. We have to give it a function name. And it's going to call that function whenever it's clicked. We're going to give it a better name than just button click because we need to handle the button, two different buttons. That's not looking good. I may veer from there. Okay, if you want to add some text to it, the technical name in a lot of programming libraries for text is a label. Now, some environments give you the ability to draw your window. You get to drag things out just like you were drawing on our flowchart program. I want some text here, I want some buttons here, and then it goes and it writes all the code for you. And that's kind of cool.
Like Visual Basic.
Visual Basic, yeah. C# does that. Java does if you're using NetBeans or Eclipse. All right. This is definitely going far field from what I want it to do. Maybe I'm just not understanding. I think they're making it too complex. So here's what we're going to do. When we create the button, if they click B1, we're going to call what are we going to call it? Handle B1, event B1. Let's just call it event 1. And then when they click B2, the command that's going to be executed is event 2. We have to provide those functions. How do we define a function? We just use DEF. We're going to give that name, either event 1 or event 2, and we're going to put some comments here. Now we need to define the buttons before that in the code. So I think I'm going to stick those functions right up here at the top. I like seeing my buttons near the my functions up near the top. So define event 1. For now, I'm going to just put a placeholder, just so we know it did something. Define event 2. Print event 2. So you see what we've added? We added some parameters added some arguments to our button creation. Command is equal to event 1, command is equal to event 2. And then we actually created those functions that handle those events. Guess I should actually test it before I brag too much. Okay, see? I click on the first button, it says event 1. I click on the second button, it says event 2. Yeah, that would be the next cool thing to do.
Mine isn't doing that.
Why is it doing what?
Mine isn't showing the event.
Well, let me pause the recorder and do a walkabout. I haven't done. So the textbook shows us how to create what's known as a label. The label gives us a place to write some information. They show us creating a label that says the number of good and the number of bad. To keep track of the number of good and the number of bad, they're using something weirder than what we've used. Instead of just typing in a number, they're using a class called int_var. I guess that's required in order to get it to work with a TK interface library. We can do that. So maybe above our events, let's do num1 is equal to int_var. Num2 is equal to an integer variable of a special kind. And we need to set both of those equal to 0. Num1.set 0, num2.set 0. Then we need to create some labels. Labels are text spots on the screen, like when you see the descriptions of buttons, you know, and the description is usually above the button. So we're going to put some labels that are counters. So let's do a label for the first one. Lab1 is equal to label. Let me make absolutely sure I get the syntax right. You specify what app the label goes on, what window it goes on, and then we specify a text variable for it. So, label, I don't think this is going to work. I think I'm putting it in the wrong place because it needs to be below where we create the app. I'm going to go ahead and keep typing it here, but then we're going to have to do a big cut and paste.
In the text, it's capital L label. Does that matter?
Yeah, that matters a lot. Thank you. Okay. So if you can't read that, that's the word text variable with no spaces in it. And then we need to pack it. We're going to stick label 1 on the left, label 2 on the right. So lab1.pack side equals left, lab2.pack side equals right. And I really bet that that's going to not be properly margined and stuff like that. Okay, so the problem is we don't have app defined yet. So take these lines of code, app is equal to TK, app title, my awesome window, app geometry, cut those guys and paste them up here at the very top under from TK enter. See what I did? I took these lines, which were above the buttons, I cut them. So I took the line that says TK parentheses and title and geometry. I don't want those there. I want them right under there. And now I've made enough changes to this that I'm nervous that I've broken it completely. I'm going to run it just to make sure I don't have any syntax errors. Okay, it's got a number there and a number there. Hey, I think that's pretty cool, actually. It turned out better than I was thinking. We could put margins on those numbers if we wanted to. We are really getting close. What's going to happen? We need to change the program so that when we handle event 1, it updates that number. It increases it. And when they generate event 2 by clicking on the second button, it updates that number. Now it'd be a okay, so when they click one of those buttons, it generates an event. It generates an event which we invoke via this command argument. So it's going to call either the event 1 or the event 2 function every time. Pardon?
Can I ask a question?
Yeah.
On the window, is there any way that they could input something into the window?
Yeah, we're going to do that on the guessing game program that we write next. Okay, this syntax looks gnarly, but we're just going to run with it. When they get a new one right, we have to get a new number. So n is equal to num1.get. We're getting the number out of it. N plus equals 1. We're increasing it by 1. And then num1.set back to our new value. Now you could do all that in one line, which is what they show in the textbook. I don't like going nuts and putting like 3 different commands in one line. Yeah, we could do it here. Yeah, just to demonstrate how you would do it in one line. Yes, sir.
I'm confused about the n plus equals 1 thing.
This is what's known as incrementing. It's the same thing as writing n is equal to n plus 1.
Okay.
Does that make sense? And if you do n times equal to, that's the same thing as writing n is equal to n times 2. Alright, this shows how to do it in 3 lines. What we're doing is we're getting the value out of that int var, num1's int var, and then we're tacking an extra 1 onto it. We're incrementing it by 1, and then we're setting int var back up to 1. We're going to do the same thing here, except we're going to do it in one line like the textbook shows. Num1 dot set parentheses num1 dot get plus 1. Let me sure I got that right. Yeah.
Was it num 1 or num 2?
Should have been 2. You're correct. num2.set, parentheses, num2.get plus 1. Just a shorter syntax. It does the exact same thing as this, but it doesn't use a temporary variable to hold the value. Is that enough, or do we have to update those labels? Let's find out. Hey, cool. Now, I don't know where the textbook is going with this, but the next thing that I would want to make it do is that when you hit a specific number, like when you get 10 right, then the game ends. Let's see where the textbook is taking it. I don't think it's doing that. We'll do that when we go with writing the guessing game version. So the guessing game version is going to be a little bit different. It's only going to have one button, make a guess, but it's going to have a place where you type a number in. And then when they get the number wrong, we're going to display a message. If they get the number right, the game ends. So let's take a break. And then we'll be back to do that. I hope you're finding this interesting. I think that writing things that actually look like programs you'd want to use in real life is kind of fun. I would rather, maybe a little bit of copy pasting would be appropriate, but not too much. I don't want to just grab the whole thing and then start cutting it, because that'll be hard to follow. Okay, so this one, let's call it GUI guess. GUI guess. Guessing game GUI is our description of it. What's the library that we need to import? Yeah, TK enter. Import TK enter, except from TK enter import everything. Alright, we learned from bitter experience that we want to create the app right off. If this isn't the first line of code in the program, like you discovered, then you just start getting weird errors later on and won't compile, even when you wouldn't think it was wrong. So app is equal to that. App.title is equal to guessing game. I don't really care so much about the geometry. I'm going to leave that off unless it turns out later we need it. I'm going to put a comment. Okay, I don't think we need a place that just displays a number, but we are going to need a place where they type a number in. So I bet that's also going to be an int var, but it's time to check the text to see how you put an input box. Data entry widgets. Things like buttons, text fields, otherwise labels, are known as widgets in this language. So here's one they're making. It has 3 text fields, a great big one for typing in something else, and then a button called Save. Let's see how they do that. Well, aren't we skipping ahead here? Okay. It's called an entry field in this language. So they make an entry field for description, and then they pack it. We're going to need to do that. And then they have a label. We're going to need that in a couple of places. For some reason, yeah, and then they pack it. They're being a little bit squirrely here and packing things as they define them. I'm not into that. Okay. So our top label ought to be like, pick a number between 1 and 100. Let's see how they did that here. We didn't. Let's go take a more careful look. They said text is equal to. That's what told us what to display on the screen for our label. So, lab 1 is equal to label. We have to specify what app. We're not going to give it a text variable because it's not displaying. Honestly, I think we could do that. But let's just run with this for now. We may go back and change it. Text is equal to, pick a number, 1 to 100. Let's put that on the top. So lab1.pack side is equal to top. And along with my general policy of run early, run often, I'm going to run it and make sure I don't have any syntax errors. Okay, hey, that's cute. Maybe we need more than that. We're also going to want a label down at the bottom. I'm really thinking that it shouldn't just be that it should say text var is equal to. So I'm going to do a quick bit of Google. Text var in Python tk enter. Okay, so you have several different data types, just like we have ints and floats and strings. If you're doing tk enter work, then you use int var or string var, probably float var too. Let's create our string var for the next one. Why? Because we're going to be changing it. We're going to be telling them if they got it wrong, you know, increase your guess, decrease your guess, that kind of stuff. So since it's going to be changing, I don't want to hard code the text of it. So let's make our string, what should we call it? The answer, the status? I kind of like status. The status is going to be a string var. And then our label 2, wait, we should probably set some text in it. Status.set. This is just a temporary text. We'll change it, you know, as we go along. No guess entered. How about that? So before they start playing, it says no guess entered. Then we need to add that to another label. So we're going to create a lab 2 or a label 2. Lab 2 is equal to label. We need to attach it to our app window. Text var is equal to status. And then lab2.pack, and let's put that on the bottom. Side is equal to bottom. It wouldn't be a bad idea to put that main loop thing, but it seems like we can run it without doing that, so I'm going to not bother at this point. Alright, it created our 2 labels. That's kind of cool. Pick a number, no guess entered. It'd be neat if, you know, it had a background color or was offset, you know, in some way, but we're going to be adding buttons, and that's going to space things out a little bit. We're going to need a guess button on the right side and in the data entry field on the left side. I certainly know how to do the button, so let's do the button first. How about just BT? Or BUT, but that looks pretty silly. BT is equal to button, and it had a lot of parameters as I recall, so I'm going to take a sneak peek at how I define my button up here. We had to put app, we had to put some guess, they had a width, and then they had a command. I'm not going to put the command yet. I'm just going to say app and text and let it figure out the width. Okay, so app and then guess. We need to pack that one. bt.pack side equals left. Now I'm going to make a change and then I'm going to undo it. So don't do this. But when I'm doing GUI programming, I like to kind of make it look like this. I put all the packs in one place, like this. And like I said, don't make this change. I'm going to undo it really quickly. So that you're creating everything in a row, and then you pack them. That's how I like to do it, but I don't want to go back and make that change. So I'm going to leave it as is. Let's run it now, make sure we don't have any syntax errors.
Text equals.
I forgot something, didn't I?
Your guess makes text equals.
Yeah, I goofed that. So not app comma guess, app text equals guess. I just changed that line. I said on the left, I really want it on the right. And then I want my input field to be on the left. And it'd probably be nice if we were using the margin padding, you know, to space it out, but it's more typing. We're going minimalist. Okay, I really wanted that button to be on the right. Guess I was feeling dyslexic. Now we need an input field. They show us how to do that in the text, so I'm going to tab away from our window here to see how to do it. They create a string var, and then they create an entry. I wonder if I can do it with an int var because we want it typed into we want it converted into a number. A lot of graphic libraries don't allow you to do that. They don't allow you to set the type of the data entry field. And if that's true, then even if they're typing a number, you're getting a string, and you have to convert it to a number yourself, just like we had to in every other case where we did input. But I believe that tkinter is sophisticated enough, unlike some libraries in Java that I know of, where it'll convert an integer variable into the text to be displayed and then back. Let's give that a shot and see if that's right. Okay. So, our guess is going to be an int var. Why don't we just set it to 50 to give them a head start? Guess dot set equal to 50. And then our entry field, we need a variable that holds our entry field on the screen, and I'm not coming up with a good name for it if we're using guess as the number. How about gentry? Gentry. Kind of odd. Alrighty. Gentry is equal to an entry field. What the heck is that master bit? Oh, I'm looking at something else other than a textbook at this point. That's confusing me. Okay. We specify the app, and then we probably specify the text variable. I'm hoping this is true. Then we're going to need to pack. So gentry.pack side equals left. I may have made a mistake here. I will find out as soon as I compile and run it. Hey, cool. That's a lot of room to type a number. But I think it's working. I want to make sure that that's working for everybody before we go on. I believe that to be all the code that we've typed except for the import. So I'm going to leave that on the screen. What are we going to have to add to our button here? We created a button, but it's not doing anything when you click it. What are we going to have to tack onto it to make it do something? We're going to have to add the event handler. So it's going to say command is equal to, and then a function name. So we're also going to have to create a function. We'll have to decide where to put that. But for now, leave that alone. Oh, and we don't have a counter yet. How many variables, how many guesses they've made so far. I guess I'm gonna punt on doing that for now as well. So let's make a field for our counter. So it's also going to be an int var. And let's set that off to 0 too. So counter.set 0. Now we need to make a label. Label 3, that's real specific, isn't it? Is equal to a label. It's attached to our app window. I'm going to scroll up a little bit. And the variable that that label displays is counter. Then we want to pack it. Where to place it's a question. For now, I'm going to just stick it at the bottom. Well, it didn't go on the bottom, it went in between them, but that's kind of neat. So every time they press guess, it's going to increase. Yeah, guess it's okay. How'd you get it over there on the... Oh, you stuck it on the left, and it put two things in a row on the left. Is that how you did it? I want to see what that looks like.
I stuck it on the bottom. If you expand the window, it's just the one line above no guess in it.
Oh, okay.
It's just when it's small like that, it looks like it's right in the middle.
All right. In that case, I am going to add the geometry line from the other program. So I'm going to go grab this line. This is my awesome when my app geometry. I'm going to go and paste it here. So after I create the window and give it a title, that's going to be my geometry for it. Let's see if that makes it look good. That's kind of spaced out. You know what? I really would just like it in the middle, but or the guess to be in the middle. What if we don't put a side on the guess at all? Will it show up in the middle? Oh, I forgot to make it back on the bottom. Okay, so this is not going to be perfect, but it's okay. Actually, what we said is that we're going to be updating the guess button with the number. Oh well, we'll do that later. All right, so here's what we did is we added a geometry to space it out, make it look a little bit nicer. And we tacked on these lines down here to create our counter. And for now, I stuck it on the bottom. So we need a button handler, an event handler. So where we create our button, we need to tack something on. Go back to the line that says BT is equal to button, and when they call it, we're going to call event. Now it's interesting to me that you don't put parentheses there when you specify the function, but we don't make the rules. We're giving it the name of the function only. I guess because if you actually put parentheses there, it would invoke the function right on the spot. We don't want to do that. Okay, so we need a handler. We need a function called event. The question comes where to define it. I'm going to be tacky and define it right above the button. As a matter of fact, take those two lines, BT is equal to button and BT.pack, cut those. See what I'm doing? BT is equal to button, BT.pack, cut those, move them to the bottom. That way all of our variables will be defined before our function is written. So that stuff was here, BT is equal to blah blah blah, BT.pack, blah blah blah, but I moved them down to the bottom. Other languages will not let you define functions in the middle of code like this, but we're going to take advantage of it. In other languages, everything is put inside a function. So all of this code would be in a function called main. Okay, so we need to define our function. It's called event. Oh, we don't have a guess. We need a variable to hold our guess.
35.
So our target for now is 35. We'll make it a random number later. Okay, it's always a good idea to print something at the beginning just to make sure that it's handling our event. Yeah? Okay, I didn't test it after I moved it. Thank you for commenting on that. Mine is still there, oddly enough. Okay, let me come back and see. Okay, so when I run it, hopefully when I click the guess button, it prints a message. Alright, success. We've got that working so far. I don't want that print statement there anymore. That was just to make sure it was working. Alright, we have a guess. What do we need to do? We need to increment the counter. So, we're going to do it in that same style, that the condensed style. Counter.set, counter.get plus 1. In other words, get the counter, add 1 to it, and then set it back to itself. Now we need to see if our guess is equal to our target. If guess.get is equal to target, colon. Now I'm writing a primitive first with print statements, and then we'll go back and fix that. Where'd that space come from? My stuff's not lined up right. Sorry. Don't know what I did there. Again, this is just a test to make sure that we have some functioning going on, that we can pull our guess out, that we can compare it to the target number and see if it's right or wrong. We really don't want it printing messages in our final result. But, alright, this looks like we are cooking. And our counter is going up. So I'm really happy about that. I wonder if we set a width on that counter, if it wouldn't be tabbed over like that. This is just an experiment. Don't necessarily type this until I confirm that it runs. Nope. Alright, never mind. Undo, abort, there we go. Okay, so rather than just printing correct or wrong, we want to do something a little bit more complex than that. If they get it right, we want to change the status to hooray, you got it right. What was our status variable called? I think it just had the clever name status. So, if they get it right, status.set hooray, you got it. If they didn't get it right, we want to tell them either to go higher or go lower. So instead of just else, I'm going to make that elif. Elif guess.get is less than target. We want to tell them that it's too high. No, too low. Status.set. Nope. Guess too low. Else, our final else, status.set. Nope. Guess too high. To make the risks higher, we should only give them like 6 guesses, you know. Have that be a countdown counter rather than a count up. But we don't want to make things too complex. It's not like I'm going to ask you a bunch of questions on the exam about graphical user interfaces, but I want you to have some experience with it. All right, nope, guess too high. Now we hard-coded the number to 35, so we know what it is. Guess too low, 35. Hooray, you got it. It would be neat if the cursor set itself into that entry field right there so that we didn't have to tab over to it. So it was already all ready to go. It'd be even more neat if after they typed a number and we hit enter, if it automatically processed without hitting guess. Now, honestly, I don't know how to do that, but I do know how to move the cursor to right there. That's called the focus. The focus is which entry field on a window that your cursor is currently gone. And I'd like to set the focus to that field. Not that it's a big deal for them to, you know, to put their cursor there. But if they're doing a lot of data entry, you know, with several fields, and then they click the save button, it'd be nice if the cursor jumped back up to the top so that they could do more data entry. So we will do that. Well, maybe we won't. Focus.set. That's what it's called. Okay. So, where's our guess field created? gentry. After the line that says gentry.pack, we're going to do gentry.focus_set. That'll move the cursor to that specific entry field. So that's the change we just made. Yeah, and my cursor showed right up there. That's really kind of a big deal because the first thing I'm going to have to do is to highlight, you know, those numbers anyway, so it didn't help. Just want you to have the idea of focus. You can set the focus on a button as well so that, you know, you've noticed that when you tab around on a window, at least in some operating systems, it'll move over to the button so that you can just hit enter on that button. Well, or so I say. No, it's not. Doesn't work on TK enter. Oh well. Okay. This is just about done.
I'm having a problem with the Boolean logic and the elif statement.
Okay. About the only thing that I can think, okay, rather than me tell you what I think an improvement would be, and I'll come help you in a second, what could be done to make that program better? More user-friendly, more professional, more fun, more whatever. I could think of maybe one thing.
Handling non-integers.
Handling non-integers, yeah, that would be a really good idea. Do a try except block. So making the target random would make it fun. Lastly, I think if you get it right, it ought to be more exciting than just, hooray, you got it. I think it ought to pop open another window, you know, a big message. said you got it right. Then if we were really awesome, we'd put a reset button and we'd start all over and stuff like that, but we're not going to go nuts. Okay.
What was the else statement again?
Yeah. So that's our event handler as it is. Alrighty. Who did the random number already? So you can tell me how to do it. Okay, cool. What do I need to add the import up at the top?
Import random.
Okay, so I do import random here, and then when I had 35, wherever that was, right here, target is equal to 35, what am I going to make that?
Random.
Random dot, is it any capital letters or all lowercase?
I think it's all lower.
It's all lower.
And in between 1 and 100. Guess too low, 75. Guess too high, I'm not going to take the time to actually keep. Sure I am. Oh, fine. Alright, took me 7 guesses. Yippee skippy. Alright, I think the last thing I want to do is to make it pop up a window if you get it right. And in a lot of programming languages, they call that a message box. I don't know why they called it a message, but they did. Let's see if that's the term that was used here. No, I don't want programming toolbox. Okay, we'll Google TK enter Python 3 message box. Google's your friend. So we're going to do messagebox.showInfo, and then we have to give the title to the window followed by the message in the window, if, you know, they win. So inside of our if, else, if, where it says hooray, you got it, let's see if this is going to work. Messagebox.showInfo, hooray, and then end quote, comma, begin quote, you got it. I don't really want to play the whole game in order to find out I got it right or not, so I'm going to change that random number back to being, I'm going to make my number between 1 and 10 just to make it really easy to guess. You don't have to do that, but so that's the line that I just added, is in my if box, if statement. See if it works. Alright, and it popped up a window. It says, you got it. It'd be more nifty if the window was right above the app itself, but I don't know how to do that. It'd be neat if this had 2 buttons like replay or quit, and if they chose replay, then it would you know, do one thing, and if they chose quit, it would do another. These are just ideas. We're not going to actually implement them. That's about it. That's about all I really want to do. Other than I'm not terribly happy with this, like, you know, not being centered and whatever.
It's neater if you leave it on that left side.
If it's on left, does it look nicer?
Yeah, it looks very nice to the thing.
That sounds good. So my counter, I'm not going to pack it to the bottom. I'm going to pack the counter to the left. At Victoria's suggestion, let's see how that looks. Oh, to the right. Well, either way,
No, that's how I had it.
that's how you had it, yeah.
Because I mean, it just shows it right next to it.
Yeah, I like that. That's cool. That's good enough. All right.
Is not defined.
Yeah, I got message box not defined as an error.
I've had that happen before. I get to add message boxes up here. It's like I have a slightly different version of Python than y'all do. And it doesn't work for y'all. So come up to that line that says from TK enter import star. Tack another one on that says from TK enter import message box. Should not have to do that because when you do import star, it ought to get every function. But it's leaving the message box off. See if that fixes it for you.
You can also write from random import rand int, right?
Correct, if you don't want to prefix it with, yeah. Exactly. Okay, guys. The homework, this is actually going to be the last homework assignment of the semester. Write a GUI using TK enter. That displays a button and a label. When the button is pressed, or before the button is pressed, the label starts off saying off. When the button is pressed, the label says on. Really a short one compared to what we've been doing. I'll gussy that up later. And let's make drop boxes for what we've done.
How did you say we import the message box?
You do from TK enter import message box. Like that. Sorry, I got to cover it up. So we created 3 programs today. Safe.py, which was the safe data entry using, the 2 possible ways of doing that, and then GUI game and GUI guess. Okay, there's a Dropbox. Please give the PY scripts you did today. And we're done for the day. If you want to hang out and work on homework, it's also totally cool. I usually stay, 20, 30 minutes extra at least.
Can you show the script for the GUI guess? I missed the And there's the code to for the pop-up ones.
Oh, sure. Right here, we added that to our if statement. By the way, I'm really impressed with y'all. I know I move up and down on the code, you know. Sometimes it's difficult to follow, and y'all do a great job of that. Also impressed. We've got a lot of good grades going in this class, which makes me happy.